All of us have experienced small sparks or crackling sounds when removing synthetic clothes, especially in dry weather. This happens often with garments like polyester saris or sweaters. Sometimes we even feel a small electric shock when touching a metal door, a car door, or an iron bar in a bus after standing up. Another powerful example of the same phenomenon is lightning during thunderstorms. These experiences occur because electric charges get accumulated on our body due to rubbing between insulating surfaces. When these charges suddenly flow through our body or air, an electric discharge happens. This effect is commonly known as static electricity. The word static means something that does not move or change with time. Electrostatics is the branch of physics that studies electric charges at rest and the forces, electric fields, and electric potentials produced by them. The study of electricity dates back to ancient times. Around 600 BC, a Greek philosopher named Thales of Miletus observed that amber, when rubbed with wool or silk, could attract light objects like straw or bits of paper. The word electricity comes from the Greek word electron, which means amber. Later people discovered that many other materials also show similar behavior when rubbed. You can easily observe this at home by cutting thin paper strips and bringing them near a television or computer screen. The strips get attracted and may stick to the screen for some time. These experiments helped scientists realize that rubbing certain materials can produce electric effects even without any batteries or wires. Inspired by these early discoveries, inventors and scientists began exploring the endless possibilities of electricity, laying the groundwork for future innovations. As knowledge spread, generations of curious minds continued to build upon Thales' initial observations, creating the foundation for our modern understanding of electricity. Today, electricity powers our homes, fuels our devices, and drives innovation, showcasing the remarkable journey from ancient curiosity to modern necessity. Further experiments showed interesting results. When two glass rods rubbed with silk are brought close, they repel each other. The same happens with two plastic rods rubbed with fur. However, a glass rod attracts a plastic rod. Similarly, silk attracts glass and fur attracts plastic. Small pith balls, when touched by a charged rod, also become charged and start repelling each other. But a pith ball charged by a glass rod attracts another pith ball charged by a plastic rod. From these repeated observations, scientists concluded that there are only two types of electric charge. One important rule was discovered: like charges repel each other, and unlike charges attract each other. This simple rule explains all the observed behaviors in these experiments. When a charged rod touches a pith ball, the charge moves from the rod to the pith ball, illustrating how the pith ball becomes electrified and behaves just like the rod that touched it. Scientists also observed that when a glass rod rubbed with silk comes back into contact with the same silk, both lose their electric effects, indicating that they no longer attract or repel light objects. This phenomenon demonstrates that opposite charges cancel each other when they meet. The property that distinguishes the two kinds of charges is called polarity, where, according to convention introduced by Benjamin Franklin, the charge on a glass rod is considered positive, while the charge on a plastic rod is deemed negative. An object without any charge is classified as electrically neutral. In the fascinating world of electricity, the interactions of charged objects showcase interesting phenomena. When a glass rod is rubbed with silk, the resulting charges exhibit unique behaviors. Bringing these materials back together leads to a cancellation of their electric effects. This process lays the groundwork for understanding the essential concept of polarity, where opposite charges attract, while like charges repel. The visual representation of positive and negative charges further emphasizes this critical distinction in the study of electrostatics.